All right, so let's look at this particular problem. We are told that what if one quarter of all subsets of size 5 of the sets, which is this, contains the element 2, determine m. So first thing we need to look at is one quarter. What is one quarter? One quarter is simply just 1 over 4, right? One quarter of something is 1 over 4 of that, and so we have that aside. Now let's look at this. We're talking about sets, right? And then when they say we need to look at subsets of size 5, simply means usually we have different kinds of subsets that we can generate from this. One, all the singleton sets are all subsets from this set, right? Even the empty set is also a subset. But in this case, we're looking at subsets which have 5 elements in them. So first thing we need to understand is this. In a set, right, the order of arrangement doesn't really matter in this case, right? 1, 2, 3 and 2, 3, 1 or 1, 3, 2 are all the same thing. This is a classic example of combination, right? So we have what's called the permutation, we have what's called the combination. But for combination, let's focus on combination since combination is what is going to help us solve this problem. Combination, in combination, we only count objects without regarding the order of arrangement. Simply put, in terms of sets, right? Like I said before, 1, 2, 3 and 2, 3, 1 are all the same thing. So the formula for combination is what? In this case, we have a total of m elements here. So we just say m, out of m elements, we are choosing 5. I want to see all the total possible subsets of this set that has just 5 elements in them. So we use this, which will give us m factorial all over what? M minus 5 factorial times what? 5 factorial. We can further expand this to m times m minus 1, m minus 2, m minus 3, m minus 4, and m minus 5 factorial all over m minus 5 factorial times 5 factorial. Now, as you can see, this m minus 5 factorial can simply cancel this m minus 5 factorial. What you are left with is m times m minus 1, m minus 2, m minus 3, and times what? M minus 4 all over what? 5 factorial. Now, these are all the total possible subset that has 5 elements in them, right? This is just the total in everything. So we want to look at one quarter of this particular case. Let's look at one quarter. One quarter is simply 1 over 4 in this particular case, which means we are looking at 1 over 4 of what? This, which is m times m minus 1 and m minus 2, m minus 3, m minus 4, all over. And 5 factorial is simply what? 5 times 4 times 3 times 2 and times 1. So if you were to multiply everything together, you get 120. And we just multiply what is 4 times 120. At the end of the day, we'll get m times m minus 1, m minus 2, m minus 3, m minus 4, all over what? 480. Now, this is one quarter of all of the total possible 5 element subsets we can get from this particular set, right? Now, let's look at the other part of this particular question. They said one quarter of all subsets of this size contain the element 2. So now, how do we know how many of this particular 5 element subset contains 2? We're saying look at the total possible number of 5 element subsets, right? That contains 2. In order to do that, imagine you have a set of numbers, right? And you want 2 to be there in that particular set of number. That means you just need to fix in 2. Since 2 is fixed, in this particular case, 2 is a fixed digit. Let's just say we have 1, 2, 3, 4, 5. 5 spots, and 2 is already fixed. So we don't need to bother about thinking of 2. we don't need to bother about thinking of where to place 2. It doesn't really matter where 2 is placed. Like I said, the order of arrangement doesn't really matter. 2 is just fixed. So in this particular case, we're only bothered about the remaining 4 elements in this 5 element subset. Just focus on the 4 elements. So if we are taking out 2 from the total number of elements in this case, we no longer have a total of m elements, but in this case, we have a what? A total of what? M minus 1 element. Since we removed 2, meaning you subtracted 1 element from it, assuming we had 7 elements and remove 1 element from the 7 elements, you get a total of what? 6 elements. So we fixed in 2. We are no longer bothered about 2. We just need to focus our attention on the number of 4, the remaining 4. Just focus on the remaining 4 elements in that 5 element subset. In order to do that, like I said, we just pick out of m minus 1, we choose what? 4. Following the same principle, we're going to have what? M minus 1 factorial all over what? M minus 1 minus this 4 factorial times what? 4 factorial. Okay, we can further simplify this to m minus 1 times m minus 2 times m minus 3 times m minus 4 times m minus 5 factorial all over minus 1 minus 4 is minus 5. So this is m minus 5 factorial times 4 factorial. Definitely these two will cancel each other out. And what we are left with is this, which is m minus 1, m minus 2, m minus 3, m minus 4 all over 4 factorial. 4 factorial is 4 times 3 times 2. 4 times 3, we know 4 times 3 is 12, and 12 times 2 is what? 24. 24 times 1 is just 24, so 5 over 24. Now, if we go back to our original question, or just the calculation from the top, remember 1/4 of this should give us this, right? 1/4 of this, so we just equate it. So which is, we have, in this case, we have m times m minus 1, m minus 2, m minus 3, and m minus 4 all over what? 4et should give us what? M minus 1, m minus 2, m minus 3, and m minus 4 all over what? 24. Now, men looking at this entire numerator will cancel out this other numerator. And what we are left with, not entirely, there's m here, so it's m over what? 480 is equals to what? 1 over what? 24, which you can further simplify, or this is our final step. We just need to multiply both sides by 480, so we have m is equals to what? 480 over what? 24, and 480 over 24 is going to give us what? 20. So m in this case is what? 20. I hope you enjoyed the procedure and how to arrive at this answer.